Okay, we are recording the meeting. So, good morning or good evening to all, and welcome to the Data-Driven Community virtual meeting. A few words about the Data-Driven Community for those who are new in our meetings, and for the recording for those who will watch it later on. I highly recommend to follow the website. Basically, everything is there. This is a screenshot from the website. As you can notice at the home page, we are managing two branches of activities. The first one is an annual conference called Future Data Driven Summit. And the second branch of activity which we run is a weekly meeting, just like today, called the Cloud Data Driven User Group. If you scroll down the page, you can see the upcoming events. On the left, this year, the Future Data Driven Summit will be held on September 25. The call for speaker is opened this month, so if you want to speak, do it fast, register, submit your session. Registration to the event has just opened about 2 weeks ago. Don't wait for the last minutes. You can register now. It's recommended. I will put all the links in the chat once the main speaker of today will start his session. And if you are fast enough, you can scan the QR code. More information about the conference and the upcoming activity you can find on the website. And you can notice on the right side that we have all the upcoming meetings of the weekly meetings, the Cloud Data Driven User Group. If you will scroll a bit more, then you can notice the board members of the community. You can contact us if you have any questions or a suggestion. Jen Joseph, he is the founder of the community. We have Anna Maria Wickel, co-admin. And my name is Ronen Arieli. I'm from Israel. I'm working as a senior consultant in the field of data platform and architecture of enterprise level systems. And I also co-admin of the data-driven community, and I will be hosting the session today. So those are the board meeting of the community. Please feel free during the meeting to use the chat for questions and discussion. This is not a conference, so we are more flexible. You can use, and you are welcome to use the chat for discussions between yourself, between us as well. And you are also welcome to use reactions. I like it a lot. I don't know why not a lot of people use it, but it doesn't interfere with the course of the meeting. If you hear something that you love, if you like something that just was said, or you want claps your hand, it's a virtual meeting, so you have the option to do it virtually. Feel free to use the reactions. Our speaker today is Hugo Kornelis. Hugo is a SQL Server expert, which is directly related to the session today. He is speaking in multiple events and user group, and Hugo is well familiar in the data platform community. So Hugo, you are welcome to share your screen and take control. You can add some words about yourself as well.
Okay, thanks for the welcome. I'm sharing my screen now, which also means that I cannot see the chat anymore. So if there are questions in the chat, please read them to me. You can interrupt me at any time. So if you have questions, ask them. Don't wait until the end.
That's okay. I will follow the chat during the session, and when there are questions, we will stop you and give you the information, but I do not see your screen.
You do not see my screen.
Actually, I see something, but it's all pink.
It says
I'm not
here
sure
that
if this is a slide.
stop sharing and reshare.
Maybe it was a slide that was without any content.
No, it was the title slide, so it's light blue with white letters. And this is the next slide. Now it's a white slide.
Yeah, I see white screen.
With letters. Do you see
I don't
my
see
name on top?
No, I don't see any content.
It
Can someone
is...
else see it? Use the chat, please. Inform us if you can see the sharing. I cannot see anything. No, other people do not see as well. And it worked before the meeting.
Try to do it in a different way then. Let's see.
Try to share the screen, the entire screen, not just the presentation.
That's what I did. Screen one. It shows here on the preview, shows the presentation, and I now says that I'm sharing my complete screen.
I see a white screen. I see like you are sharing. I see something that you shared, but I see white screen, like the screen is empty.
Let's move ahead a bit to a slightly fuller screen.
Okay, try to share the...
Do you now see a picture with a lot of no's on it?
No, nothing. Someone is writing in the chat something, so when you will send it, I will know. Oh,
Okay,
now I see.
Stop sharing and try sharing the application instead. Perhaps that works better.
Usually sharing the screen is better, but...
Yeah, but apparently not today. Does this work? Does this work?
No. White.
I don't know what's wrong.
Okay,
Let's try yet something else. How about now?
Let me take the sharing again to me. Inform me that you can see my screen, and then you will take it back. Okay, tell me if you can see my screen.
I can see your desktop now.
Okay, still the same. Someone in the chat. Alexei also informed he cannot see the screen. Share your screen, please.
I've stopped the presentation, so let's see if I can share my...
Show the screen without the presentation. Just show us the screen itself.
Yes. You should just see a Windows background picture and my menu bar. Start bar.
Nothing.
That is so weird.
Yeah, and it worked before we started the meeting. Okay, disconnect and join the meeting. Leave the meeting and join the meeting again.
I will do that. I will see you in a minute.
Okay, we are here. Can someone else share his screen? We will see that it's working. Just say in the chat if you are okay with sharing. I will give you permission. Oleski, you help us with the information. Do you want to share your screen for a second?
Excuse me, it was a question to me?
Yeah, I just wanted someone will try to share.
Okay. Let me try then.
I will give you permission. You cannot yet.
Oh yeah, it is not enabled yet.
Let me make you a presenter for a second. Okay, you should be able to share. Please share your screen for a second, just that we will confirm that other people can share as well. Oh no, that's not good because you cannot share as well. I don't see your screen. So the issue is not with your side, probably. It's with the meeting. That's not good. That's never happened before. You are showing your screen now, right? Okay, that's great. That's never happened before. It's a new. We don't have anyone backup. Okay, I leave you as a presenter, Oski, and Itzik also have permission. I will leave the meeting and I will join again. Let's see if it helps. I don't see a reason that it will help, but I really don't know what is happening here. It never happened before.
Hello again. Looks like Teams dropped me out.
Wait, I see that everyone is still here. Let me check permission. Okay, Hugo, I need to give you permission. What is your name? Here. Make presenter, change. Okay, Hugo, you can share your screen. Hopefully it will work.
Let's see, my camera should be on, my microphone should be on.
Yeah, your
In the
camera is
meantime,
on.
switched to a different browser because I couldn't even reconnect anymore. But let's see if this works better. So I'm trying to share my screen now.
Okay, now we can see your screen.
Chrome
I can see your
wins.
screen.
Firefox loses
Okay.
today.
This is
Okay,
new. I never saw this.
rough start, but let's not linger too long on that. We are finally live. Hello, welcome to 5 Stages of Grief, the internals of a hash pill. For the record, this is a 500 level session. This is a session targeted towards people who do not need explanation on what a hash match is or on the basics of what a spill is. We are going to dive into the internals of that hash pill. Welcome here. My name is Hugo Kornelis and I make SQLServerFast.com. SQLServerFast.com is the website that I created when I realized that as awesome as execution plans are and as many improvements there are for execution plans, the documentation for them sucked. And instead of whining about it, I decided to do something about it. So I created the execution plan reference where you can find intense amounts of detailed information about everything in execution plans. Of course, this is a reference, so it is not an easy place to learn about execution plans. People asked me about that, and in response, I started making the execution plan video training, which is a series of very in-depth training videos on execution plans. Some of them are available for free. Some of them are sold for a, I think, very reasonable fee. And those fees are even more reasonable if you buy access to those videos before June 15 and use the code CLOUDY. I think capitalization is important. So cloudy with capital C. This code is valid until June 15. I also have a lot of other content on SQLServerFast.com, like my blog, like my articles, and the most important for now, the resources. So if you go to SQLServerFast.com and then go to other presentations and presentation resources in the menu, you will see a list of all the sessions I have decks for, and you can just click the link and download the slide deck and demo code. The session for today doesn't have a demo code, it's slides only, but for all my sessions, slide deck and demo code are freely available, so you can have the slides of this session or of other sessions if you want to. I do other stuff as well in the community. I have my work, consulting and training, and you don't care about all of that at all. The only thing you really care about when I do my intro is this: my email and my Twitter. If you have questions during the session, just ask them, type them in the chat or raise your hand and wait until you're asked to be unmuted. But if you have questions later, if you go over the material again, or if you watch this on the recorded video and you run into something and you have a question, just send me an email or send me a tweet and I will try to respond to you. So we are going to talk about the internals of a hash spill. And when I first thought of this session, I saw some similarity with the grief caused by a hash spill and the stages that are observed in psychology in grief processing. And when I have a new idea for a session, what I always do is I have a broad idea in my head what I want to do. Then I write an abstract for it and I start submitting, but I don't really build the session until it is actually accepted because, well, some sessions simply are not interesting to the community. I think they're fun, others disagree. They never get accepted. So why would I spend time on building a slide deck for that? But once it's accepted, I start building my slide deck. And that happened with 5 stages of grief. So I decided, let's make sure that I don't from head misquote psychological studies. And that's not my profession after all. Let's first verify that what I think are the 5 stages of grief is indeed the accepted knowledge. Turns out psychologists even disagree that there is something such as 5 stages of grief. And those that do believe them have different ideas of what those 5 stages are. So I just picked what seemed to be the most popular one and the one that I personally recognize with my own grief processing when I had to go through it. So the 5 stages of grief, according to some psychological theories, are denial, anger, bargaining, depression, and acceptance. Now, this session is not about grief, but let me tell you, even though I made this kind of joke about the 5 stages of grief in the title, grief, mourning is a very serious issue. And you should, if you have grief, if you are mourning, and if you struggle, never hesitate to reach out for help. There are always people who are willing to help you if you need help. So reach for that help. There is no shame in asking for help. This is the most serious thing of the whole session I'm going to say, but I think it's important to say that when I touch upon such a subject. But for the rest, we will be talking about the 5 stages of a hash spill. And those stages roughly correspond to those stages of grief. So a hash spill begins with dynamic destaging, which is has subphases of the in-memory hash join, the hybrid hash join, the grace hash join, and the recursive hash join. Then we're going to talk about dynamic role reversal. We're going to talk about bailout, and we're going to talk about bit vector filtering, and all of that in just one single hour. And before I even start there, I'm going to do a very brief overview of what a hash match does, just so we're on the same page. Like I said, I expect my audience to know this already, but I want to be sure that we're on the same page, that we use the same terminology. So the hash match operator works in 2 or 3 phases. The first phase is the build phase, where it reads data from the top or first input, officially called the build input. And then for each row, it uses a hash function to find the number of the so-called bucket to use. And then it stores the row in that bucket in a hash table. If you don't know what a hash table is, or if you don't know what buckets in a hash table are, make a mental note to look that up after this presentation. I do not have time to go that deep because I want to go into the hash spill. After doing this, all the rows from the build phase are in memory in a hash table, distributed across hundreds of thousands, perhaps even millions of buckets. So instead of a single table with millions of rows, we have hundreds of thousands or millions of buckets with, on average, just a few rows in each. Then the probe phase starts, where we read from the second input, which is called the probe input, and once more use the hash function to determine the hash value to determine which bucket to use. That is the bucket where the matching rows must be, if any matching rows exists. But because those buckets only have a few rows, it doesn't take much time to search for matches in that bucket. And that is where the hash match gets its efficiency from. Depending on the type of join requested, there may be a final phase where SQL Server does a scan through the entire hash table to look for rows that were not matched at all during the entire processing, and then processes them as needed for that join type. Now, very important here is the memory grant. The optimizer tries to determine how much memory is needed to hold the entire build input in memory, because that is where the hash table lives. But of course, the optimizer has to do this before the query starts, so it's all based on estimates, and estimates may be wrong. Since SQL Server 2017 for batch mode plans, and since SQL Server 2019 for all plans, memory grant feedback can improve bad memory grant estimates. But even with memory grant feedback, there is always the possibility that the memory grant is not appropriate for the amount of memory actually needed. This memory grant has to be reserved before query execution starts. On my own laptop, that's not a problem. I have Teams running and I have nothing else running, PowerPoint, of course, so I can just allocate all the memory that the laptop has and nobody is bothered by it. But on a production server, even though they probably have way more memory, they also have more users. So if everyone just start reserving 500 gigabytes for each query, then that is not a good idea, because the server will run out of memory and everyone will have to wait before your execution starts. So that is a reason, sorry, wrong click. That is a reason why you do not want your memory grants to be overly large. However, you also don't want them to be too small, because once the query executes, the memory grant cannot be increased. And that means that when a hash spill tries to store more data in the hash table than it has available, it has to spill. And we all know what a spill does, right? When a hash match operator spills, it means it has to store part of its data in tempdb, which is slow, and it has to adapt its algorithm, which also is slower. That's all we know, and that's all we need to know, right? But perhaps we want to know more. Perhaps we want to know what data exactly goes to tempdb and how exactly the algorithm changes. Perhaps you don't, then I don't know why you're watching. I do, so I started researching this, and this has resulted in this session. So let's look at the 5 stages of a hash spill, and it starts with denial. When SQL Server starts running a hash match, it assumes that there is no problem. No problem at all. Everything will fit in memory. This is called the in-memory hash join. And I have made some slides to show you how that works. So this rectangle here represents the memory that is reserved for our hash match. and we are going to create a hash table. A typical hash table would have hundreds of thousands of buckets, but that would result in a very tiny font. So for this walkthrough, I assume that there are only 9 buckets. So there's 9 buckets allocated in the reserved memory. And at that point, we open the build input, we read the first row, and from that row, we are going to compute based on the specified columns and using the hash function, what the hash is. The hash is 4, so this row has to be stored in bucket 4. This is done by pointers, so the data is actually just stored somewhere in memory, and a pointer connects it to the start of bucket 4. Then we read the next row, we compute the hash again, this time the hash is 8. So this row is stored in bucket 8, again using a pointer. And we continue doing that, reading the row. This is once more bucket 4, so it is added to the data already in that bucket. And so we keep reading data and storing it until at the end, all the data from the build input is in memory. Now, to you, this picture may seem pretty hard to read and very complex. But because it's built with pointers, a computer can handle this very easily. Now, there's one thing I do want to say. The actual real structure of hash tables used by the hash match operator is a bit more complex than this. But that extra complexity doesn't affect the spill process. So I decided to visualize it using a simpler version of a hash table than what is actually used. So now that all the data from the build input is in memory, we can open the probe input and grab a row from there. And like I said, that row is also pulled through the hash function to determine the bucket number. And now SQL Server doesn't have to read all the data in memory. It only needs to read the data in bucket 4 and compare those rows with the probe row to produce matching rows or to produce the correct data for non-matching rows in the case of, for instance, an outer join or a semi-join. So we produce the correct output depending on the join type, and then we read the next row, once more compute the hash, and now we only have to read the data in bucket 7 to produce the matches, or to produce the correct output. And we continue processing the probe rows like that until we are done, and then we have all the data. This is the ideal case. There is no spill. We denied there was a problem, and indeed there was no problem, so we are happy. Enter the hybrid hash join. The hybrid hash join is the actual algorithm that SQL Server uses, because this algorithm, this in-memory hash join, if you only use that algorithm, then you actually get errors if you run out of memory. We don't want errors. So what SQL Server actually uses is the hybrid hash join, which is an algorithm that starts as an in-memory hash join. So let's go back in time a bit. Let's go back in time to when we were busy reading the build input and storing everything in memory. So we started as an in-memory hash join. We already have a lot of data in memory, and we find yet another row from the build input. But we are out of memory. There is no room anymore in our memory ground to store this new row. So what do? We get angry. Or in terms of the hash match algorithm, what we actually do is, even though we started as an in-memory hash join, the hybrid hash join algorithm says, okay, then we are now going to degrade into a so-called grace hash join. Okay, what is a grace hash join then? I'll tell you. At this point, SQL Server knows there is more data in the build input than available memory. I cannot fit everything. I have to do something about it. Now, this hash table has thousands of buckets, or 9 on my PowerPoint slide. What SQL Server does is it divides all those buckets into several groups called partitions. And you see that on the top left, I have made 3 partitions of 3 buckets each. Now, this is unrealistic in two ways. First, the number of buckets is insanely low. Like I said, in reality, it will be a much higher number. And second, the partitions are not made from consecutive bucket numbers, but based on a hash. So the data is hashed to find the bucket number, and then that bucket number is again hashed to find the partition number. So in reality, even if you had 9 buckets and 3 partitions, partition 1 would perhaps be buckets 2, 4, and 8. Partition 2 would be 1, 4, or 5, and the remaining buckets would be partition 3. They would not be consecutive. But for ease of visualization, I have chosen to make the buckets of 3 adjacent, to make partitions of 3 adjacent buckets. At this point, we are also going to add tempdb because, like I said, spilling means we are going to use tempdb. SQL Server now looks at the number of partitions, in this case 3. It subtracts 1 and then multiplies it by 2. That's 4. And that means that SQL Server creates 4 files. I don't know how they are called internally, but for ease of understanding, I call them build 2, build 3, probe 2, and probe 3. And the 2 and the 3 in those file names refer back to the partition numbers. So we have a build and a probe file for partition 2, and we have a build and a probe file for partition 3. We have nothing for partition 1. We are now going to go through all the buckets of partitions 2 and 3, or even go through all the buckets, but when the bucket belongs to partition 1, we're going to ignore it. So the first relevant bucket is bucket 4. Bucket 4 has several rows. One by one, we read those rows and copy the data, or rather move the data to build file 2. And as you see, the bucket number is also stored. We could later recompute it again, but that would be a waste of CPU. So we store the bucket number along with the data. And we do that for all the rows in bucket 4. And as soon as that data is safely stored in that file, we don't need it in memory anymore. So we are freeing up memory. We do the same for bucket 5, but bucket 5 is empty, so we're done quite fast with that. And then bucket 6 has 1 row. That row is also going to be copied and then to build 2 and then erased from memory. And we're also going to do the same for buckets 7, 8, and 9, so that we now have copies of that data in build file 3, and we don't need that in memory anymore. We still have all the same data stored, but only 1/3 of it is still in memory, and the rest is in 2 files on tempdb. We lost no data, but we did free a lot of memory, which means that we can now finally continue the process we were doing. So we call partition 1 the active partition now. And then we are going to compute the hash for the row that was still waiting to be processed. It happens to be a row for bucket 4. Bucket 4 belongs to partition 2. Partition 2 is not active, so this row is temporarily set aside also in file build 2. Then we're going to read the next row. We're going to compute the hash. This is a bucket that is part of the active partition, so this row does get stored in memory. And we keep doing that, reading build rows, storing them either in memory if they're in partition 1, or in the build files if they are partition 2 or 3. And at the end of the build process, we have our memory fairly full again, and we have 2 files with data for partitions 2 and 3. So once more, all the data from the build input has been read, processed, and stored, but it's not all in memory. Part of it is in memory, part of it is in files in tempdb. This is just the build phase. So now we have to do the probe phase. The probe phase will start by reading the first row, computing the bucket number. Bucket 4 is part of inactive partition 2. So this row is now also temporarily set aside in the file probe 2. So here we copy the probe rows that we cannot deal with right away. The next row we read as a hashes to a bucket 2. So this is a row that we can process immediately and produce the correct output for. And we keep doing that, and at the end, when we have read everything from the probe phase, from the probe input, we have all the data from the probe input that hashes to an inactive partition stored in the probe files. And for partition 1, we now have processed all the rows and we know that we have the complete output for partition 1. So we have already produced all the correct rows for partition 1 only. We have produced nothing for partitions 2 and 3 yet. But because we have now produced everything for partition 1, we don't need the memory in the in-memory hash table anymore. So we can throw away all that data and look, we have space available again. So at this point, we call partition 2 the active partition, or 3, SQL Server chooses one of the partitions. Let's say it chooses partition 2. And now we want to process partition 2. But for that, we do need to have the build input in an in-memory hash table. We have it now in a file in tempdb. So we read the data from that file and store it in the correct bucket, row by row, until we finally have read all the data from build file 2 and stored all those rows in the correct bucket in memory. Once that is done, we can start reading from file probe 2, and this is a row that belongs to bucket 4, so we can now start looking for matches and producing the correct results by looking only in bucket 4. And we could do the same for the next row and the next row, and so on and so on. So the next row is for bucket 6, and we produce the data for that, and we continue with that until partition 2 is done. Then we once more clear the memory, make partition 3 active, load partition 3 from the build file 3, and then process probe file 3 to produce the remaining results. And at the end, we have all the results we need. It just took a lot longer because we went through the data multiple times. We had to store data in tempdb, read it from tempdb. So yeah, we have reason to be angry because it was slow, but at least we got there. Now, what I described is the Grace hash join in the context of a hybrid hash join. There's also something called a full Grace hash join, which is basically the same idea, except that we start without an active partition. So this is when we, right from the start, basically we skip the denial stage and we're going to say, oh, we're probably going to spill anyway. So let's just first create, in this case, 6 files. We read the build file, the build input, and we write all the rows to the files build 1, 2, and 3. Then we read the probe input, we write everything to the probe files 1, 2, and 3, and then we make the partitions active one by one and follow the process of reading from the build input, storing in memory in the in-memory hash table, reading from the probe input, and producing results one partition at a time. That is the full Grace hash join. It is rarely used, but there are some cases where that is used instead of the Grace hash join as part of the hybrid hash join. But typically, SQL Server starts the hash match as a hybrid hash join. So, that was the wrong button. I was looking at the slide. I was like, why do I have that slide? But I accidentally clicked the back button. My mistake. So this is not everything yet. There is also something called the recursive hash join. And perhaps you have already realized one of the situations where this might happen. So let's once more travel back in time. We are going back to the build phase after we switched from hybrid to Grace. So we already made 3 partitions. We already started adding data for in build files 2 and 3, and more data in the in-memory hash table for partition 1. And we just keep receiving more and more and more rows. Hey, another row. Which bucket would this be? Bucket 1. But we're out of memory again. Even after splitting the input in 3 parts, partition 1 still has too many rows in the build input, and we run out of memory. and yet we need to store yet another row. And that's where we start the recursive process. At this point, partition 1 is further subdivided into 2 or more even smaller partitions. I call them 1A and 1B here because that's easy for me to recall that they are subdivisions of what was originally the partition 1. But I assume that SQL Server internally uses different terminology for them. However, now that we have done this, we have partition 1A and 1B, and now we suddenly have two active partitions, which is of course not the case and not the intention. So what we need to do is create two more files in tempdb. And for the record, on the screen, I will now shrink the file sizes. That is not something that actually happens. The files in tempdb are not pre-sized. They just grow with every row that you added. It's just a visualization where I made the square a bit smaller so that I have space for more build and probe files. So this is just two extra files being allocated. And at this point, SQL Server can once more go through the hash table, copy all the data for partition 1b to the file build 1b, remove it from memory, and store more build rows in there. And then the process continues basically as if SQL Server had started with 4 partitions already. Now, of course, we can, if this continues long enough, even run into the same problem again. Partition 1a might still be too large, then we simply do it yet another time. That's why it's called recursive hash join. This is truly a recursive process where we keep splitting partitions into smaller subpartitions until we have a partition that is small enough that all the build data does fit in memory. Now, this is just one of the cases of situations of a recursive hash join. There is also a slightly different case where you also run into a recursive hash join. Once more, we are in the build phase. We have degraded from hybrid into Grace. We have 3 partitions. We have loaded a lot of data, but now, while loading, there was even more data in build file 2. Now, those files have no size limit. They can grow as large as you want. But of course, we already know that somewhere later in the process, we want to load all that data from build 2 back into the hash table. And that won't fit. And SQL Server knows that because SQL Server will keep track while storing data in the build files of how many rows and what size it stores in those build files. So at the end of the build phase, when partition 1 is fully in memory and partitions 2 and 3 are fully in their build files, SQL Server can look at those counters and say, oh, this will be a problem later. I have no problem now, but later, once I start processing partition 2, I will run into a problem because build file 2 has more data than my memory grant, and I will not be able to fit all that data in memory when I need to fit it in memory. So at this point, SQL Server already knows it needs to split partition 2 into partitions 2A and 2B, which once more means that it has to add 2 extra files. At this point, you might expect SQL Server to go through the data in the file build 2AB to put them all in the correct build files, but it doesn't do that. That would be a waste of time. It just leaves one build file marked as build 2AB. And again, internally, this will be done different. This is still the combined data. We will sort that out later, but we already have split the partitions so that during the probe phase, we can store the data that belongs to partition 2A in probe 2A. Of course, data that can be processed immediately because it's the active partition, we process that. And then data that belongs in partition 2B will go to the file probe 2B. So at the end of the probe phase, when we have processed everything for partition 1, We also have stored all the rest of the probe data in the correct probe file to A, to B, or 3. But for the build data, we still have a problem because we have the data for build 2A and build 2B in one combined build file, and build file 2B is still empty. That's weird. So how are we going to handle that? Well, we will make the next partition active, 2A in this case. And now we're going to load from the combined file build 2AB. We read a row. It's part of the active partition. We store it in memory. Nothing new. We do that for the first 3 rows in this example. But then we encounter a row that is part of 2B. We don't want that in memory. We want that in the file 2B. So we copy that row to this file 2B. And once we have done that for all the rows in the file build 2AB, all the data that belongs to 2A will be in memory, and all the data that belongs to 2B will be in the file build 2B. And from here on, we can continue the process as I showed it before, and we will actually get all the correct results. So that is the entire dynamic destaging process. And that was also stage 2, anger. Yes, we are mad. Yes, we are unhappy with the performance. But let's try to negotiate. Let's try to find methods to shave off a bit of the rough edges. So let's return to that recursive hash join. And let's once more return to where to the end of the build phase. I just showed a scenario where at the end of the build phase, we figured out that the data in build 2 was by itself already too much to fit in memory. But there's also a possible scenario where at the end of the build phase, we see that the combined data of build 2 and build 3 could be in memory. We made 2 partitions, but the amount of data in those 2 partitions combined would have fit in memory. Again, because SQL Server keeps track of the amount of data in each file, it can determine this now. It knows the memory grant, it knows how much data is in each of the files, so it can determine, hey, I created partition 2 and partition 3 as separate partitions, but perhaps I should have created a single partition for partition 2 and 3. Again, we're not going to do anything about those build files. We'll sort it out later, but now we only need a single probe file for that combined partition. And then the process continues as we've seen before. We read a row, we compute the bucket. It's not an active partition, it goes in the correct probe file. We read a row, we compute the bucket. It is the active partition, so we process it. And we keep reading rows. This is also not the active partition, so it goes in the probe file, and so on and so forth, until all the probe data has been processed if it's partition 1, or stored in probe 2 and 3 if it's partition 2 or 3, or rather if it's partition 2 plus 3, because that's now our single partition named 2 plus 3. We clear the memory, and now the next partition becomes active, partition 2 and 3. But we don't have a single build file, we have 2 build files for this. Well, the solution is simple. Read the data from file build 2, store it in memory. Then also read data from build 3 and store it in memory. And now we can start processing rows from probe 2 and 3 to get the correct data. So that's already a small optimization where, yeah, we're in a sucky place. We have bad performance because we spill, but we gain back a bit. There's more to be gained by dynamic role reversal. Now, dynamic role reversal is not something that takes place during or after the build phase. Dynamic role reversal is something that is decided after completing the probe phase for the first partition. So we still have partition 1 in memory. We have processed everything from partition 1 already, and we are ready to start with partitions 2 and 3. But again, let's assume that the amount of data we read was slightly different. So at this point, we're going to make partition 2 active. And we wanted to process this partition. Normally, we would start loading from build 2 into the hash table and then produce results by reading probe2. But look at those two files. And remember, SQL Server has kept track of how many rows and what size rows are in those files. The hash match algorithm is known to be efficient with a small build input and a large probe input. In this case, when I look at the screen, I see that the build input is larger than the probe input. So what does SQL Server do? It reverses the roles. So the file build2 now will be used for the probe file phase. And the file that was originally called probe2 is now called build2 because we're going to use it during the build phase. Now we cannot just do this. For an inner join, there is no difference. We can switch the inputs and we get the same results. But for instance, a left outer join or a right anti-semi join or any other join type that has left or right in it, you cannot just do this. A left outer join B is not the same as B left outer join A. But A left outer join B is the same as B right outer join A. So when SQL Server reverses those roles, switches the build and probe inputs, it also reverses the join type from left to right or from right to left. And because HashMatch has support for all join types in both a left and a right version, it can always do this. And that's why dynamic role reversal works. And now we have a smaller build input and a larger probe input. And we need to load less rows into memory and then do the probe input. And we have gained a bit more. This dynamic role reversal is only possible for partitions that start in tempdb. The partition that remains active during the whole hybrid hash join cannot be role reversed. The rest can. Good. Bargaining gave us some benefits. We're happy. Until depression hits. Because there's even more things going on if you look at a hash spill. We're going to talk about bailouts. And for the bailout scenario, we have to return. And there's actually two bailout scenarios. So for the first scenario, we have to return to the recursive hash join. And in this scenario, we have already split partition 1 into partition 1a and 1b. And we get one more row, and that is also part of partition 1. But our memory is full again, so we need to recurse. But on the slide, you see that partition 1a has only a single bucket left. So there is no possible way to divide this partition even further. Now, of course, in a real situation where the hash table has hundreds of thousands of buckets, that will not happen after 1 or 2 recursions. But there is a point in SQL Server, and I don't know whether there is a maximum number of recursions or whether it will actually keep recursing until it reaches the point where you have a single bucket partition, but that is definitely the hard limit. Perhaps SQL Server stops earlier, that is not documented, but there is definitely a hard bucket, a hard limit, that if a partition has only a single bucket left, and it still doesn't fit in memory, then we have a problem, because how are we going to fix this? We cannot divide the partition into something smaller. We cannot have half a bucket. If this happens, then what SQL does is it will at this point switch to a full grace join. It doesn't start at a full grace join, but at this point it switches to a full grace join. So 2 more files are created for partition 1a and 1b, 1a, which is now also made inactive. All the data we already had in memory is moved to the build file, and those files can continue to grow. So we can now process everything in the build input. Everything is in files. There is no limit anymore. The entire build input will fit in those 4 files. And yeah, then we read everything from the probe input, and that also fits in those files. So after this initial setup, we are now at the stage where we have all the data from the build input and from the probe input in build and probe files in tempdb, and at least one of the build files, perhaps more if you're really unlucky, but at least one of the build files cannot be partitioned any further and is too large. The second scenario for build out, we will return to this later, but first, the second scenario for build out occurs at a different time, and that is when a single bucket in a build file is too large. So at the end of the build phase, we once more look at the counters and we see, oh, build file 2 has to be split into 2A and 2B. But the data division is very skewed. You see that almost everything in build file 2 belongs to partition 4. So even if we create partition 2A as just that single partition and 2B as the rest, we also know right now that build 2A will still have too much data and it will not fit in memory. That is not a problem now, but it will become a problem once we want to process build 2A. And we cannot solve that problem by partitioning it, by dividing it into smaller partitions, because it is already a single bucket partition. Now, how does SQL Server know this? Previously, I told you SQL Server keeps counters of the number of rows and the size of the rows in each build file. That was a slight lie. It actually keeps those counters per bucket. So SQL Server knows the total size of build 2AB, but it also knows how much of that size is bucket 4, how much is bucket 5, and how much is bucket 6. So at this point, SQL Server can already predict that, that build 2A will be too large. And it knows that it cannot subdivide it any further. So again, we have this problem. However, in this case, the active partition, partition 1, is not a problem. So we can now continue with the probe phase as normal and produce all the output for partition 1. We still store the rest of all the probe rows in their respective probe files. Now, we have seen 2 different scenarios of bailout, but in both cases, either immediately or after processing partition 1, we are left with several build and probe files in tempdb, and at least one of those build files will not fit. So how are we going to fix that? There is at least one single partition that has a build file that doesn't fit in memory, and we cannot split it because it's a single bucket partition. Well, we also have the probe file for the partition already in tempdb. We know its size, so perhaps dynamic role reversal will fix this. Then we are happy. Negotiation has worked. We have solved the problem. Because the size of the probe file doesn't matter. It's only the size of the build file that matters, because that's the file that we want in the hash table. But what if both files are too large? Now reversing them won't help solve the issue. They will still be too large. The build file will still be too large. At this point, the hash join algorithm is simply impossible. Now, before you say, oh, so then I will get a runtime error. No, Microsoft doesn't like runtime errors. Microsoft doesn't like bad performance either, but it likes runtime errors even less. So what SQL Server at this point does is it says, I still have alternatives. I also have a merge join algorithm and a nested loops algorithm. Now, it will not change the execution plan to use those operators and then re-execute, but it will use those algorithms for that partition of those partitions only. So if you have just one partition where this problem occurs, then for that one partition, bailout will happen. And even though it's the hash match operator doing the work in the execution plan, it will for that algorithm, for that partition, use a merge join or a nested loops algorithm, not the operator. the algorithm. So let's look at what that means. So the merge join algorithm, if you know what merge join does, you know that both inputs have to be sorted by the join key. Those files we created, they are not sorted at all. So before we can even start doing the merge join, we must first sort the build input by the join key. Well, problem we have, we can sort. There are sort algorithms in SQL Server. Yeah, but remember that build file was larger than memory. So now this sort that is just needed as a prerequisite for merge join will itself spill to tempdb. Now, I'm not going to talk about the internals of a sort spill. I don't have time for that. But that is again using a slower algorithm and using more IOs on tempdb just to sort this data. And once the data is sorted, we need to store it somewhere. So the sorted version of the build input is also stored in yet another new work file or work table in tempdb. Yikes, that's a lot of work. And remember, it's not just the build input that needs to be sorted. No, the probe input needs to be sorted too. And that input was also larger than we have available. So again, a second sort that will spill and that will create more output to save the sorted results. But at least then we can use this efficient balanced line processing of the merge join of the two sorted inputs. Well, except that merge join has a one-to-many and a many-to-many variant, and the many-to-many variant, the one-to-many variant can only be used if there is a known and guaranteed one-to-many relationship between the data, which is not the case for a hash match. So we need to use the many-to-many merge join algorithm, which is slower and once more writes data to tempdb. So if I review all this sort with a spill and a copy of the data, yet another sort with a spill and a copy of the data, and then a many-to-many merge join with more IO, it doesn't sound like a merge join algorithm is a good idea. Perhaps we should look at the nested loops algorithm instead. So how does that algorithm work? Well, we simply read one row from the build input, and then we read the entire probe input, compare the data, and produce results. That's easy. But now we have results for only one row. So we read the next row from the build input, and then we, once more read all the rows from the probe input. And again, and again. For each row from the build input, we have to read the entire probe input. And that probe input is a file in tempdb, and it's pretty large because it was larger than the memory grant. And those memory grants are typically quite large. And we have to do that for every row in the build input, which also didn't fit. So it's also a large input, so probably a lot of rows. So we have to read a very large file an incredible amount of times. That doesn't sound good either. They're both terrible ideas. And yeah, that's why this is stage 4. This is depressing, and if your hashmatch operator does this, you even have a lot of time to be depressed because it will run for a long time. What SQL Server does is at runtime, based on what it has counted while filling those files, try to pick the least sucky one in your situation. How it does this is not documented, but it can do either a merge join or a nested loops algorithm based on a runtime choice. Choosing the least sucky of two sucky algorithms doesn't make it good. It's still sucky. Sorry, I can't make it better. And that is depressing. But it's also reality. Hashmatch works that way. And of course, hopefully, it doesn't often work that way. The cases where you run into a bailout are very extreme. It should be extremely rare. The cases where you run into a spill and use the other stages are more typical. They happen. You can try to get your memory grants perfect. You can try to get your estimates perfect. You will never succeed. Spilling will happen. Accept it. And once you accept that, you are ready to start optimizing right from the start. And that's where bit vector filtering comes in. Bit vector filtering is not a stage that comes at the end. Bit vector filtering is an optimization that is done throughout the process because we already know that all those bad things can happen. We have accepted that they can happen and we have anticipated upon it. So while we created the data in the files build2 and build3, or build2a, build2b, and build3, because this also applies after recursive hash join. While creating the data in those build files, SQL Server kept a bitmap where for each partition it had one single bit saying there is data in this partition or there is not. That means that this bitmap was initialized with only zeros when we started writing the build files, and every time we write a row in a build file, we flip that bit to 1. It's a tiny bit of overhead. We do a bit more extra work, but we get a great payoff of that later. Because now look what happens when we start the probe phase. We look at the data, we compute the hash, we say it's bucket 4. That is not the active partition. And once more, I lied a bit before because I wasn't ready to accept everything yet, but now I have accepted things. So at this point, what really happens is that this row isn't immediately stored in build 2. No, we first check the bitmap to see, is there anything for partition 2? Yes, the bit is set. We have no clue what kind of data is there. That is in file build 2. But this row might produce matches. So we're going to check that later, and we are again going to store it. Yet another bit of extra overhead and no saving. Of course, for bucket 2, nothing changes. We can process that immediately. The real change is if we find a row from the probe input, we hash and we find bucket 8, and now the bitmap says we never saw anything in bucket 8 during the entire build phase. Well, what I originally would have done was store this row in probe 3 and then later at one time read it back from probe 3, search the empty bucket 8 and conclude that there are no matches. But since the bitmap already tells me that there will be no matches, if there's no data it cannot match, we can now already process it. Ignore the row for an inner join, return the row for a right outer join, or whatever the join type dictates. We now already know that the row that we're currently processing will be a non-matching row, and depending on the join type, we can produce the correct results for it, and we don't need to store it. So with this optimization in place, the end of the probe phase after partition 1 has completely been processed and we are ready to start with partitions 2 and 3, the data in the probe files will not look like this because some of those rows were already processed and not stored in the probe files. So we have less data in the probe files. And when you have less data in the probe files, then the chance that you can do dynamic role reversal on some of those partitions increases. Because of that, the chance that you need to do recursive hash join decreases. And there might even be rare cases where, because of this bit vector filtering, a bailout can be prevented. So because we accepted our fate, we accepted that hash match can spill, that we need to go through all those stages and that we can even run into a bailout. And because we then said, okay, after accepting this, we create this bit vector filter, we saved some performance. So these are the stages of a hash spill. The dynamic destaging process means that SQL Server starts as a hybrid hash join, which means it assumes an in-memory hash join until it degrades into a grace hash join, which might then, in the worst case, turn into a recursive hash join. Dynamic role reversal mitigates some of the damage. Bailout is a very extreme scenario where multiple recursions still don't solve the issue and you really run slow. And bit vector filtering on top of it all tries to alleviate some of the worst pains. Are there any questions?
I think the people are still stunned.
I'm sorry, I didn't understand what you said.
I'm saying that people are still stumped. They are still if you want to speak, please use the chat. Hand up with the reaction. We cannot speak all together.
Okay.
Okay, you can speak. You can open your mic.
Okay, if we use a memory optimized metadata in SQL Server 1.9 and forwards, does it has any influence on the process of the hash join?
The sound quality is a bit bad, but I think you asked if using in-memory memory optimized table has an effect. Is that indeed what you asked?
No, I'm asking if we are using a tempdb in which the hash join splitting is being done. If you're using memory optimized metadata in tempdb, will this influence the process?
No. Very short answer,
The same
no.
process.
The hash match has two inputs, which are subtrees in the execution plan. They might be a single operator. They might be an entire Christmas tree of operators. They produce the input for the build input. They produce the input for the probe input, and the hash match processes that. That is all done in the working memory of the hash match plus the allotted memory in the memory grant. And we only go to tempdb for those spillings. And what I do not know is whether memory optimized metadata in tempdb has a lot of influence on reading and writing to those work tables. However, given the name of the option, memory optimized metadata, not memory optimized data, I assume that it doesn't work much.
Okay. And another question, I'm using column store index, but
Yes.
from SQL Server 1.7 and forward, I can use also non-cluster index on the column store index on the table.
Yes.
So is there any case of hash join in this case when we're using joins in this case of column store index and non-cluster index?
Basically, the two are unrelated because the getting the data into the execution plan will be done somewhere else in the execution plan by, in this case, probably a column store index scan. Or if the non-clustered index is covering, it might be a non-clustered index scan. Or if it's a very selective non-clustered index, it might be a non-clustered index seek plus a key lookup into the column store index. But in all those cases, those are other operators, and those operators produce data that is then flowing through other operators until it finally reaches the hash match, and the hash match just gets a row from its child operator and does something with it.
Okay. So
only relevant
We have another question from Matt.
The only relevant connection between column stores and hash match is that if you use a column store, you have a quite large chance that you will use the batch mode version of hash match, which still can spill. And I assume it's basically the same process when spilling, but all the documentation I found was about the row store hash match. So I cannot guarantee that the internals are the same in that case, but even a batch mode hash match can spill. Yeah.
We have another question for Matt on the chat.
I see in the chat, I now have the chat open, a question from Mate Varkas. If a partition does not fit in the memory and need to be partitioned again, this means a next spill level. I think that might be the case, but I have never found any documentation that ties the spill level that the execution plan reports to those phases in the internal process. The only thing I really know is the higher the spill level, the higher your pain. Nothing else has been documented on that. So it's a reasonable assumption, but I cannot confirm it because there is absolutely no documentation on that I have ever been able to find. Any more questions?
Not at this time. I do want to mention that it's very hard to find the answer to math question because you actually need to check the memory itself to do the reverse engineer. You need to check the memory itself in order to check if it is done in parallel or in another level of spilling. So I'm not sure that we can get the information unless someone from the SQL engine team will give us this answer.
Yeah, and I doubt they will. But
Me
yeah,
too.
to really know for sure, you would need
it's a
someone's
very good,
source code access.
it's a very good question. I might try to give the answer to myself. As I said, the way to do it, as I see it, is you need to actually check the memory itself. And if you read the memory, you can actually know if it is done now in parallel or it is done like it finished the first spill and now it will be done in another level. I'm not sure that it's very important for us for the actual daily work, but it's interesting.
I think it's not really relevant to the daily work, and I don't expect Microsoft to document at that level. The only thing where I would say it's a shame that Microsoft didn't document it and didn't put anything out there that allows me to find it and document it is that there is nothing known on what each spill level means. The execution plan reports with spill level 3, and I look at it like, yeah, okay, thanks, but what are you telling me? And there is no information to understand what spill level 3 differentiates from spill level 4.
Yeah. After the meeting, by the way, please collect all the information that you can pass, and we will share it when we will share the recording. Usually, I share the recording on the social media. So in the first comment, I also give a link to the download, whatever the speaker can provide. So we will
If you
want
give me a few seconds, I'll plop a link in the chat.
The people that will see the recording do not have the chat. Chat
No,
is not
you can
recorded
you
on
can copy it
Teams.
from the chat and then put it in the first comment for the recording. So then you have it, and
Okay.
everyone who's online right now will have it as well.
Okay.
So
This way we can do as well.
copy.
Okay, if we don't have
This
any
is a direct link
questions.
this is a direct link to the page where you can download the slide deck.
Okay, that's great. This is exactly what I need. I will put it when we will show the recording. Thanks a lot. It's a really advanced and very interesting session. So I want to thank Hugo. I remind everyone the call for speaker for the future data driven is open. So if you are in the side of the speakers, or if you're familiar with a speaker, one of the top speakers that you want him to speak in the event, ping him, remind him, Hugo, I haven't seen your session yet, so don't forget to submit. We want you.
I will read whether I'm available. What was the date again?
The event itself is on September 25. The call for speaker is now.
September 25. Yeah, I will not be able to make that. That is the week that my daughter gets married. On Tuesday is her official marriage, and on Saturday is her party. I am not going to go to a conference in between those 2 days.
Okay. Our loss. Just remember, it's a virtual conference, so you can do it from the wherever she is married.
Okay, I thought it was a live conference. Oh.
No. This is, as much as I know, and I checked it, last year it was the biggest virtual event in the world for data platform. And
Okay.
we expect to have even bigger this year, at least we want, but it's a virtual. The biggest physical event on data platform, as you know, is PAS Summit.
Yes.
Okay, so we are virtual user group, virtual community, virtual conference.
Okay. I'll check it, and perhaps I will add some submissions. But
This
nothing
will be
promised yet.
great.
I need to check how busy I will be that week, because of course my daughter
Take your
comes
time
first with the
in this
marriage
to
plans.
everyone. Thanks everyone for joining us. We will see you next week in the next user group meeting. Register to the Future Data Driven Summit as participate. It is open. I gave the link in the chat at the beginning of the session, and you can also find it on social media. So thanks a lot. Thanks, Hugo.
You're
We
welcome.
will end the meeting for today. Bye bye all.
Bye.